Sauce here. This is a video lesson on creating the graphing form of a quadratic equation by a method of averaging the x-intercepts. What do we mean by that? Well, if we started with a quadratic equation in standard form, or viewed as what we call a polynomial, we might want to change the form of how this equation is organized so that it looks different, or it looks, it's organized in a way that makes it easy to see the vertex and the dilation factor, which is considered graphing form when it's organized like this, in this pattern, in this form. Y is equal to A times then in parentheses x minus h all squared plus k. If we can convert this quadratic equation into the form that is equivalent but changed, then we will be able to see that the vertex is located at hk, and with the dilation factor A, that's the amount that we could stretch the whole thing out or compress it, then we'd be able to graph it more quickly, more readily. So how do we do that? Well, there are a couple different ways. We're going to do it by investigating what we know about this equation. We know that its orientation is up because the coefficient of the x squared term, or the thing that's multiplying x squared, is positive. It would be oriented down if that 2 were negative. So we were oriented up. And we know that we have a dilation of 2. That means that what we're multiplying the x squared term by, this, what will become this a value, doubles vertical distances. This is a parabola that is being stretched out. We also have a familiar method of finding the x-intercepts. The quadratic formula can be applied, and when we do, with an a value, which is what multiplies or is the coefficient of the x squared term, which is the same a value that we're looking for in this graphing form, is 2. The b value is the coefficient of the x term, that's 4, and c is the non-variable coefficient, negative 30. The quadratic formula is x is equal to negative b plus and minus the square root of b squared, or 4 squared is 16, minus 4 times a times c, which I'm going to write as a 30 because the negative I'm going to take care of by changing the sign of this negative into addition, all over 2 times a, or in this case 4. Simplifying, negative 4 plus and minus. Now let's see what we have under the radical. We've got 4 times 2 is 8, and 8 times 30 is 240. When I add 16, that's 256, and 256 is the square of 16. So the square root of all of this simplifies to be 16 divided by 4. Next step, negative 4 minus 16 is a negative 20, divided by 4 be negative 5. The second x value is negative 4 plus 16, which is 12, divided by 4 is positive 3. I've found my 2 values of x, which are the x-intercepts. I am ready to present the beginnings of a graph of this equation with this information. I know that I have got an x-intercept at -5 and an x-intercept at 3. And I know that it's going to be oriented up so that these vertices, or these, I apologize, these intercepts are going to be the intercepts of a parabola that starts high, goes under the x-axis, and comes back up in order to be oriented up. So the vertex is going to be somewhere down here. Because of symmetry, because I know that all parabolas have reflection symmetry over a vertical line that goes through the vertex, then I know that the vertex has to be evenly in between 3 and -5. If I average these two intercepts, then I will find the middle point at -1, which is the line of reflection symmetry that will go through the vertex. With that reasoning, I know the x value of the vertex. So if I average the two vertices, said it again, if I average the two x-intercepts that I previously found by adding them together and dividing by 2, I will get the x value of the vertex. And in this case, that's -1. If I have the x value of the vertex, I can put that into my equation to find the y value. I'm going to put -1 into my equation. When I do, I get -1 squared is +1 times 2 is 2. -1 times 4 is -4, so the -4 and 2 will be -2. And then subtract 30 more gives me a y value of the vertex of -32. So way down at -32, I have the vertex of my parabola, which might be off my page. It's so low. The vertex, its coordinates are -1, -32, and in graphing form, that's the value of h and k. I'm ready to produce my graphing form. I have the value of a, I have the value of h, and k. The graphing form of this quadratic is y is equal to that value of a times x minus the value of h. Be careful, we're subtracting a -1, so we can turn that into addition, squared plus the value of k, which is a negative. If we had started with the graphing form, then we could read the vertex right away, plot its coordinates, and then understand that the parabola that I would draw would be stretched out by a factor of 2. Vertical distances of the parent parabola would double.